Hello everyone, welcome back to another video for the series. I'm Inoq, and today I brought a very exciting problem from IMO. And first of all, I apologize for being quite sloppy lately, and that's because I don't like make excuses, but I was praying for AMC because uh, actually at November 5th there's AMC, and then it's November 8th when I have KMO, so I also felt an urge to solve few AMC problems because Olympiad style problems and competition style problems are very different, and I really need distinguished honor roll this time. So yeah. Then without further ado, let's solve this problem. Let determine all functions such that for all. This is true. Okay, so I think what we can do, first of all, what we can do is substitute like zeros for a and b, because how nice that our domain and codomain are all integers for f of x. So when a equals 0, when a equals 0, we have f of 0 plus 2f of b equals f of b. And then we have when b equals 0, we have f of 2a plus 2f of 0 equals f of 0. Wait, no, f of a. Now, just notice that we don't really want f of a plus b here because it's just not clean. And we also don't want f of 2a. So let's try and change them. So substituting the first equation, let's call this 1, let's call this 2. Substituting 1 to 2, we get this equals f of 0 plus 2f of a. Therefore, f of 2a is equal to 2f of a minus f of 0. That's what we know so far. And let's substitute our given equation. Let's substitute our first equation to our given equation. So we have f of 2a plus 2f of b is equal to f of 0 plus 2 times f of a plus b. And notice that we can change f of 2a to 2f of a plus f of 0 plus 2f of b equals f of 0 plus 2f of a plus b. And next, we are going to do something just like, I'll say, balancing equations in chemistry. We're going to balance them like this. So I just moved this one. Now subtract 2f of 0 on both sides. 2f of 0 like this, so that let g of x equals 2f of f of x minus f of 0, where g is integers to integers. So divide 2 on both sides, we get g of a plus g of b equals g of a plus b. And we have our and because g is from integers to integers, we know that g must be linear. And because g is linear, f is also linear because we can treat f of 0 as a constant. Because although it is changing, it's not it's the same when we set them. So therefore, it is linear. So we just need to find linear solutions to this. So how we should do is, let's just say f of x equals cx, because that's what we usually do. Maybe plus k. No, let's do it later. So substituting, we have 2ac plus 2bc equals c times a plus b. So we have 2a plus 2b equals c times a plus b, and we have c equals a plus b over 2 times a plus b. Therefore, c equals 2 works. But we also need to take when c equals 0 in consideration, not because we can cancel this 2, but this is a trivial solution. So when f of x equals 0, 0 plus 0 equals 0. So that works. Now, notice that I think we can move our thing. So f of x equals 2x plus k. We need to see if this also works, because now I think this is yeah, I think it works, but just in case, we have 4a plus k plus 4b plus 2k equals f of 2a plus 2b plus k. This is equal to 4a plus 4b plus 2k plus k. So this works. Nice. So this is our solution. So f of what? f of x equals 2x plus k for k in integers, and f of x what are the solutions? Now let's investigate this slowly again. So here we just proved that f of x is linear, so that's great. Now how do you know that this is our only solution? So because we know that f of x must be linear, we know that every equations are in the form of f of x equals cx plus k. So honestly, we can just substitute that right away, but after finding our trivial solution, c equals f of x equals 0, we also know that there's another equation of the form f of x equals 2x. Now, the other ones they don't work. The other ones just don't work, because we were not able to derive any other solutions other than this. But for those who are skeptical, because this is what I actually did first, I just substituted this one. So I have 2 ac plus 2k, no, plus k plus 2bc plus 2k equals f of ac plus b. So ac plus bc plus k, this is equal to ac squared plus bc squared plus ck plus k. So I just grouped them, so we get cancel these two, AC times C minus 2 plus BC times C minus 2 plus K times C minus 2 equals 0. So we have C minus 2 times BC plus K equals 0. So it's either when C equals 2 or... So what this tells us is that every equation, functions in the form of Cx plus K must satisfy this, because it is if this, then that. But we know that this is true, so this is also true. Or when C equals K equals 0 from here. Because even though A and B are variables, we can't really manipulate them. So we just proved that they are the only solutions, and that's what's going on here. So I think noticing this one was very important. Oh, but before that, substitution, that was our first kick. Noticing this so that we can make an equation of Cauchy type. For this one, I'm not sure if we do have to prove it again, but I think I will just prove it, because this is not that hard to prove. It's just using induction. So 0, 1 equals plus G of B, G of 1. G of 2 equals G of 1 plus 1. G of 2 equals G of 1 plus G of 1. Sorry. This is equal to 2 times G of 1, and G of 3 is equal to G of 1 plus G of 2, and then substituting back in, we have G of 1 plus 1 plus G of 1, and then so on. So when we substitute G of n, we have G of 1 plus G of n minus 1. This is equal to G of 1 plus G of 1 plus G of n minus 2, all the way until we have G of 1 plus G of 1 plus, until we have 1 plus dot 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 plus G of 1. And notice that for this to be G of 1, there should be n minus 1 of these. Because notice that here we have 1, 1, 2, 3, 1, 2, 2, 3, n minus 1, n minus 2, and then we have one more, so n minus 1. So this is equal to n G of 1. So by induction, we proved that this is linear. It's not that hard to prove, and I think I will just include them because, who knows. And I think many of us might miss this condition, trivial solution, because I also missed it when I first solved this problem. And yeah, so I think this problem was really fun and interesting. So if you enjoyed this problem, please don't forget to like and subscribe, and I'll come back with another very intriguing problem. Then thank you, and see you tomorrow. Bye.